in session number 1, what we discussed fundamental principles. We discussed that there are 4 fundamental principles of counting. One is an addition principle, and another is a multiplication principle, another is a principle of negation or subtraction principle, and then we discussed division principle. These are the 4 important principles of counting. Depending upon the nature of the question, I will use a particular principle. Addition principle is used when the events are happening parallelly. I will use addition principle. When the events are happening serially, one after the other, I will use a multiplication principle, right? Subtraction principle is used to find out the negation, that means total cases minus the cases where the condition is satisfied. If I want the remaining cases where the condition is not satisfied, then I will use the subtraction principle. Division principle is used in grouping related problems. And then we also discussed a good number of problems based on arrangement of digits. We discussed. Then we discussed some exam based models. These are the problems that we discussed in session number 1 and 2. These are the problems which we discussed: addition principle, multiplication principle, subtraction principle, division principle, arrangement of digits, and exam based models. Right, now let us get into a problem solving. I hope you are all ready to go. Now let us straight away get into the problem. First one, the sum of the factors of 8 factorial. There is a number, it seems. The number is in factorial, which is 8 factorial. 8 factorial is nothing but 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Any factorial can be written as power of prime basis. Any factorial number can be written as a power of prime basis. You can write any factorial as a power of prime basis. For example, 4 factorial is there. 4 factorial is 4 into 3 into 2 into 1, which is 24. Can I write it as 2 cube into 3? 8 into 3 is 24. Any factorial number can be written as a power of prime basis. So, till 4, what are all the prime numbers? 2 and 3. Till 8, what are all the prime numbers? One is 2, another is 3, another is 5, another is 7. So, we have to find out the highest power. Divide 8 by 2. 2 4s are 8, 2 2s are 4, 2 1s are 2. 4 plus 2 plus 1 is 7. I am finding the highest power of 2 in 8 factorial. Next, I am finding the highest power of 3 in 8 factorial. 3 2s are 6, these is 3 square. Similarly, for 5, 5 1s are 5. Again, for 7, it is 7 power 1. That means 8 factorial, it is nothing but as a power of prime basis is 2 power 7 into 3 square into 5 power 1 into 7 power 1. Any factorial can be written as a power of prime basis. From 1 to 8, what are all the prime numbers? 2, 3, 5, 7. Highest power of 2 in 8 factorial is 7. Highest power of 3 in 8 factorial is 2. Highest power of 5 is 1. Highest power of 7 is also 1. 8 factorial is 2 power 7 into 3 square into 5 into 7. Sum of the factors which are odd numbers. Factors should be an odd number. So, it cannot be multiple of 2. Any number multiplied by 2, it becomes an even number. 2 power 7, it is out because the factor should be an odd number. And it should be of the form 3m plus 2. when divided by 3, it gives a remainder 2. That means when you are dividing a number by 3, remainder 2, that means it is not divisible by 3. 2 power 7 is out because factor is an odd number. 3 square it is out because factor should be of the form 3m plus 2. Remaining it is. What are all the factors? Yesterday we discussed by using fundamental principle of counting how to determine the factors. 5 power 0, 5 power 1, 7 power 0, 7 power 1. So the factors are nothing but 5 power 0 it is 1. 5 power 0 into 7 power 1 which is 7. 5 into 7 power 0, 5. 5 7s are 35. These are the 4 factors which are odd numbers and which are of the forms 3m plus 2. 3m plus 2 we have not even seen. These 3 into 0 plus 1. I want 3 into m plus 2. These is not possible. This is 3 into 2 plus 1. 3m plus 1. These also not possible. 5 is 3 into 1 plus 2. 5 is 3 into 1 plus 2. 35 is 3 into 11 plus 2. So, I need to add the factors which are of the form 3m plus 2. 5 is of the form 3m plus 2. 35 is of the form 3m plus 2. 5 plus 35, it is nothing but 40. Sum of the factors for this question is nothing but 40. Question number 1, very good exam based question. Again, second time I am explaining. Step number 1, there is a number that is given in the question, that is 8 factorial. I wrote 8 factorial as a power of prime basis. How to write it? From 1 to 8, what are all the prime numbers? 2, 3, 5 and 7. Highest power of 2, highest power of 3, highest power of 5, highest power of 7. 2 power 7, 3 square, 5 power 1 and 7 power 1. Highest power of 2, 3, 5 and 7. Now see here, I want the factor which is an odd number. So 2 power 7 is out. I want the factor which is of the form 3m plus 2. When you divide a number by 3, remainder is 2. That means it is not divisible by 3. 3 square is out. From 5 power 1, 7 power 1, all the combinations are 1, 7, 5, 35. I took the factors which are of the form 3m plus 2. 5 is 3 into 1 plus 2. 35 is 3 into 11 plus 2. And I need to add the factors. 5 plus 35, answer is nothing but 40. Question number 1, very good question. Question number 1, I hope the idea it is clear. Question number 2, these where most of the students might do a mistake. First see here, right? This is a very good cat replica question, sir. This is a cat replica question. First let me see. This is also a cat replica question. You will understand the beauty behind these questions once we start solving. This is again placement and SSC exam replica question. Again it is placement and an SSC replica question. I did every possible variety in our class. Every possible variety. This is again an exam model. This is again an CAT exam replica question. Again it is an exam model. Like that, every possible question is taken from the previous year exams, be it CAT exam, be it SSC exam, be it bank exam and everything. Number of distinct rational numbers. Now method number 1. Traditional method, how the students will solve it, then I will tell you method number 2. If possible, I will also tell you method number 3. Method number 1, traditional method, number of distinct rational numbers. Underline this word distinct. Underline this word distinct. When I say distinct, for example, 1 by 2, the value is 1 by 2. 2 by 4. 2 by 4, what is the value? 1 by 2. Distinct. Distinct means all should be unique to each other. If I wrote 1 by 2, I cannot write 2 by 4. I cannot write 3 by 6. Are you all with me? Because the value comes out to be 1 by 2. The value comes out to be 1 by 2. He is asking for the rational numbers. That is the first thing. Distinct keyword is clear to me. Next one, such that 0 less than x less than 1. What is x value? X is a fraction which is m by n. That means 0 less than m by n less than 1. 0 less than m by n less than 1. That means fraction should lie from 0 to 1. That means numerator should be less than denominator. Numerator should be less than denominator. I hope it is clear. 1 by 2, 2 by 3, 3 by 4, 5 by 6, 7 by 8. All these cases are where the numerator is less than the denominator. Now, what they will do is, most of the students, what they will do is, they will do counting. Let us count it. If m equivalent to 1, n equivalent to, can I take n value 1? 1 by 1. 1 by 1 is 1. Is 1 less than 1? No. M equivalent to 1. N can take 2, 3, 4, 5, 6. 1 by 2, 1 by 3. What are these values? 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6. These are the values. All the values lies from 0 to 1. Next one, m value 2. M should be less than n. So, n value 2 is less than 3, 4, 5, 6. So, these where most of the students do a mistake. 2 by 3, 2 by 4, 2 by 5, 2 by 6. Here double counting is there. 2 by 4 and 1 by 2 both are same. 2 by 6 and 1 by 3 both are same. Ensure that 2 by 4 and 2 by 6 cases are eliminated. M is 3. M is less than n. M is less than n. So, 3 is less than n equivalent to 4. 5 and 6. These nothing but 3 by 4, 3 by 5, 3 by 6. 3 by 6 is 1 by 2. Double counting. M equivalent to 4. N is nothing but 5 and 6. 4 by 5, 4 by 6. 4 by 6 is 2 by 3. Double counting. M equivalent to 5. M equivalent to 5. N equivalent to 6. 5 by 6. 5 by 6. So, how many total cases we got? Total cases are these one case, these second case, third case, fourth case, fifth case, sixth case, 7th, 8th, 9th, 10th and 11th. So, total what will be the answer? Answer is nothing but 11. These is nothing but the traditional method where a student is slowly understanding the question and solving it step by step. Avoid double counting. Avoid double counting. Where are all double counting? It is there. 1 by 2, 2 by 4 and 1 by 2 both are same. And then 3 by 6 and 1 by 2 both are same. 1 by 3 and 2 by 6 both are same. Next one, 2 by 3 and 4 by 6 both are also same. So, these total cases are eliminated. I hope it is clear. Please read the question. This is where you will lose marks. It is the distinct. Distinct means double counting should be avoided. Distinct means double counting should be avoided. This is the beauty of this kind of CAT exam questions where you feel that you know the problem, but while doing counting you will do mistake. But this method number 1 is taking little time consuming method. Method number 2, Anil Nair's approach. Method number 2, please write down. Method number 2. Method number 2, Anil Nair's approach. What is this approach? Now see here. Anil Nair's approach. First, I'll read the question. Find the number of distinct rational numbers. Distinct means double counting should be avoided such that 0 less than x less than 1 and x equivalent to m by n. 0 less than m by n less than 1. That means there is a condition that is imposed. There is a condition that is imposed on a rational number x equivalent to m by n. Yesterday I told you, whenever there are conditions imposed on a problem, I will use selection. I will not use arrangement. I am selecting some people. In a class of 30 students, I am selecting the students who got greater than 90 percentile in CAT examination. I am selecting the students who are good in mathematics. I am selecting the students who got great height. I am selecting the students who are good in extracurricular activities. Whenever the selection word is coming, how will you select people? You will select people based on a criteria, based on a condition. If the condition is satisfied, then the people are selected. So whenever there is a condition imposed on a question, I will use selection. That means how many values are there? Out 6. Out of 6, I need numerator and denominator. Out of 6, I will select 2. 6C2. In that 6C2, NC2, it is nothing but n into n minus 1 by 2. So 6C2 is nothing but 6 into 6 minus 1 by 2, which is 15. This is where you will do mistake. In that one, which all cases should be eliminated? 2, 4. 2 by 4 is 1 by 2. Question is distinct, right? 2, 6. This case is eliminated. Next one. 3, 6. This case is eliminated. 4, 6. This case is eliminated. Answer is nothing but 6C2 minus 4. 15 minus 4, which is nothing but 11. 15 minus 4, which is nothing but 11. No condition, no counting related anything. Always remember, please write down in your notebook, whenever there are conditions imposed on a particular problem, whenever there are conditions imposed on a particular problem, I will use selection. I will use selection. So out of 6, select 2. Out of 6, selecting any 2 is 6C2. Out of 6, selecting any 2 is 6C2. What are these 4 cases? These 4 cases are the cases where the double counting will be formed. 2 by 4 and 1 by 2. 1 by 2 already taken, 2 by 4 is eliminated. 2 by 6 and 1 by 3. 3 by 6 and 4 by 6. These 4 cases are eliminated. So answer for this question is 6C2 minus 4. Kindly reply in the live chat if this method is clear to you. Is this method clear to you? There is also one more method, that is quotient method, which I will discuss a little later because I have to give an introduction to the quotient function and it is a little time consuming. By using quotient function also you can solve this problem. Everybody kindly reply in the live chat if this concept is clear to you. 6C2 minus 4. 6C2 minus 4. Idea clear, right? 6C2 minus 4. Next one. Third question number 3. A is such that X is a. Everybody please reply, sir, if this idea is clear. Everybody kindly reply, sir, because today's class I know it is a little tricky, right? X such that X is a prime number less than 30. Number of distinct rational numbers. Whenever you are solving permutation and combination, write down underline the important keywords. If you miss reading the question properly, you will get more cases. A is such that X is a prime number less than 30. 2, 3, 5, 7, 11, 13, 17, 19, 23, and the next one is 29. 29. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total there are 10 prime numbers. Total there are 10 prime numbers. Total there are 10 prime numbers. Number of distinct rational numbers. A rational number is of the form m by n, whose numerator and denominator belongs to A. M will take a value from A, N will take a value from A. Are there any conditions imposed on the question? No. If there are no condition, if this is a rational number, X equivalent to M by N, it is a rational number. That means M can be less than N or M can be greater than N or m can be equivalent to n. M can be equivalent to n. Are you all with me? There are no conditions imposed on a question. There are no conditions imposed on a question. Method number 1, traditional method. Method number 1, traditional method. Method number 1. What is the traditional method? Let us see. These is nothing but numerator by denominator. Suppose if a numerator is 2, numerator it is 2, denominator can be, first I will take these two cases, then I will come to m equivalent to n. Denominator can be any other value, 3, 5, 7 till 29, 3, 5, 7 till 29, 2 by 3, 2 by 5, 2 by 7 till 29. Suppose if the numerator it is 3, I am not taking the case 3 by 3, 2 by 2, that I will take little last. Denominator can take any other value, 2, 5, 7 and so on up to 29. Similarly, if the numerator it is 5, denominator will take other than 5 every value, 2, 3, 7 till 29. That means if you observe, if the numerator is 2, how many more values denominator can take? 3 plus 3, 6, 6 plus 3, 9. So here it will take 9. Similarly, if the numerator is 3, it will take 9. So each value is taking which, how many values? 9, 9, 9, 9, 9, 9. Like that 10 values are there. 10 9s are 90. 10 9s are 90. All the cases we got. 2 by 3 we got, 2 less than 3, 3 by 2 also we got, 90. This is where the students will tick mark the answer as 100. Why? Because they will take the cases as 2 by 2, 3 by 3, 5 by 5 and so on up to 29 by 29. Again read the question. Question is a distinct rational number. Question is distinct. 2 by 2 is 1, 3 by 3 is 1, 5 by 5 is 1, 29 by 29 is 1. Please don't add all these 10 values and do it. All these value will result in 1. So 90 plus 1. Answer for this question is nothing but 91, not 100. From where you will get 100? 90 cases where the numerator less than denominator, numerator greater than denominator. You will take 10 cases where numerator equivalent to denominator, 2 by 2, 3 by 3, 5 by 5, 29 by 29. That is incorrect. Why? Because question is distinct. Question is distinct. Question is distinct. So all these 10 values are nothing but one value. There is one value, that value of the rational number is 1, where numerator equivalent to denominator, 90 plus 1. I hope the idea it is clear. Nothing but a simple counting problem. Again a time consuming method. This we will not use it if it is asked in the examination. I hope it is clear why 100 it is mistake. Method number 2. Method number 2, Anil Nair's method. How I solve the question is, for me reading the question, half the problem is done. A is equivalent to x such that x is a prime number less than 30. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. There are 10 prime numbers. Are there any? There are no conditions imposed on a rational number. There are no conditions. There are no conditions on the rational number. Numerator by denominator. So, if there are no conditions, I will use arrangement. If there are conditions, I will use selections. Arrangements. Arrangements means I will use permutation, which is NPR. NPR. They can be arranged among themselves. Numerator less than denominator, numerator greater than denominator. Out of 10, I can arrange any two numbers 10p2. There is one case where numerator equivalent to denominator. This case can handle both the cases, numerator less than denominator, numerator greater than denominator. This case can handle numerator equivalent to denominator. Exactly, that is what, whether it is NPR or NCR, these are basically introduced to directly write down or to reduce the counting mechanism, right? This is an optimized way of doing the counting. 10p2 plus 1. This is nothing but 10p2 plus 1. 10p2 plus 1. Answer for this question is nothing but 91. Answer for this question is nothing but 91. 2, 3, 5, 7, 11, 13, 17, 19, 23, 21. Please, these two questions are extremely important. This will give us a new learning, right? If there are no conditions in the question, use permutation. If there are no conditions in the question, use permutation. Otherwise, use combinations. Everybody kindly reply if this third question is also clear to you. If this question number 3 is also clear to you. 10p2 plus 1. If there are no conditions in the question, use arrangement. If there are no conditions in the question, use arrangement. If there are conditions in the question, use selections. If there are conditions in the question, use selections. I hope it is clear. Kindly reply if this idea is clear to you. Everybody kindly reply if this is clear to you. If this is clear to you. Idea clear, right? Question number. That is not a condition. Is there any condition on numerator and denominator? Right? This is not a condition, sir. These are the values a rational number can take. These are the values a rational number can take. Right? The value has to be distinct. That is not a condition. Right? I hope it is clear. Right? Condition means on the values of numerator and denominator. When I say condition is only numerator should be less than denominator, or only numerator should be greater than denominator. These are the conditions on the numerator and denominator, right? Numerator and denominator, right? I hope it is clear. Next one. Number of 3-digit numbers of the form XYZ such that X less than Y and Z less than Y. X less than Y. Number of 3-digit numbers are of the form. Now see here. First concept. We will use a concept of series. I told you a shortcut. Anil Nair's way of solving a series problems. Here it will be very, very useful. First we will discuss that. I will repeat it. 1 into 3 plus 3 into 5 plus 5 into 7 and so on up to 29 into 31. 29 into 31. I told you in the previous classes, right, how you can write this answer orally. What is the shortcut? If n numerical values are there, make them n plus 1 numerical values. Make them n plus 1 numerical values. Make them n plus 1 numerical values. Write down first 2 numerical values. Write last 2 numerical values. 1 and 3 difference is 2. Go 2 units before. Go 2 units after. 1 by. Difference between 2 consecutive numerical values is 2. 2 numerical values became 3. I told you this shortcut in the series problems. In the series problems, how to write these series directly without calculating it. Again I am saying 1 and 3, 3 and 5, 5 and 7, 29 into 31. The difference, it is always constant. Write 1 and 3, 3 and 5, 5 and 7, 29 into 31. So difference is constant. N numerical values, make it into n plus 1 numerical values. N numerical values, make it into n plus 1 numerical values. Write down the first two and write down the last two. 1 and 3 difference is 2. Go 2 units before. Go 2 units after. 1 by. Difference is 2 units. 2 numerical values are becoming 3. One more example, then I will solve this problem. By knowing this shortcut, you can reduce a lot of time. 2 into 5, 5 into 8, 8 into 11, and so on up to 32 into 35. 32 into 35. 32 into 35. Now see here. 2 into 5. Again last one, it is 32 into 35. 2 and 5 difference is 3. Go 3 units before. Go 3 units after. Go 3 units after. 1 by. Difference between 2 and 5 is 3. 2 numerical values becomes 3. Minus, minus. Minus, minus. Why outside minus came? Negative, negative. If I add, I will get negative. Negative into negative, it is positive. Negative into negative, it is positive. These, if you know this shortcut, you will get this answer very, very, very fast. Let us see. Let us solve this question. Number of 3-digit numbers. Number of 3-digit numbers which are of the form x, y, z. X, y, z. X is less than y. X is less than y. Z is less than y is greater than z. Z is less than y and y is less than z. Suppose if I take x is less than y. Suppose if I take y value 1, x value will become 0. X value will become 0. So 0 cannot be possible because it's a 3-digit number. So this case is not possible. Y1, x0, this case is not possible. So let me take y value 2. If y value it is 2, x is less than y, so x will be 1. Y is greater than z, so 2 is greater than z. Z can be 0 or 1. 2 is greater than 0, 2 is greater than 1. If y it is 3, x is less than y. What are the values that x is less than y? 1 less than 3, 2 less than 3. Y is greater than z, so it is nothing but 0, 1, 2. Now if you observe, if x is taking y value, z will taking 2 values. If x is taking 2 values, z is taking 3 values. If it is 4, x is less than y, so it is 1, 2, 3. These nothing but 0, 1, 2, 3. So here it is nothing but 3 into 4. Similarly, if it is 9, if it is 4, I got 3 values here. If it is 9, I got 8 values here. These nothing but 0 to 8. So here it is nothing but 8 into 9. So the series is nothing but 1 into 2 plus 2 into 3 and so on up to 8 into 9. Already we discussed this shortcut. 1 into 2, 2 into 9. Difference is 1. 1 unit before, 1 unit after. 1 by 1 into 1 by 1 into 2 numericals are becoming 3. Minus, 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 minus. So these 0, minus into minus, it is nothing but plus. So it is nothing but 8 into 9 into 10 divided by 8 into 9 into 10 divided by 3. 8 into 9 into 10 divided by 3. So which is nothing but 720 divided by 3. 720 divided by 3, it is nothing but 240. 720 divided by 3, it is nothing but 240. I hope the idea it is clear. So right, 720 divided by 3, it is nothing but 240. This is method number 1. This is method number 1. Method number 1. Method number 1. By using series logic. Yesterday we told you place value shortcut, that also can be used. right? So what is method number 2? Method number 2. Method number 2. Suppose if xyz is there, if xyz is there, right? Because x is less than y, z is less than y. Repetition of the digits. Repetition is not allowed. Repetition of the digits is not allowed. Triple one, it will not satisfy the condition. Repetition of the digits is not allowed. So this can take any value from 0 to 9. So this is 10. One digit it is fixed. It is 9. And two digits are fixed. 8. So it is 8 into 9 into 10. Yesterday I told you hundreds place. This is x less than y, z less than y, x less than y, y greater than z. Yesterday we discussed this logic. Hundreds place less than tens place greater than units place. Hundreds place less than tens place greater than units place. Three place values can arrange among themselves in 3 factorial. There will be two cases. There will be two cases. So it is nothing but 8 into 9 into 10 into 1 by 3, which is nothing but 240, which is nothing but 240. Yesterday we discussed, suppose if I take an example of 1, 2, 3, 1, 2, 3, the 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. Three numbers can be arranged among themselves in 3 factorial. That is the reason 3 factorial here. Now see here, hundreds less than tens place, tens place greater than hundreds place. Hundreds is less than tens place, it is greater than units place. Hundreds it is less than tens place and it is greater than tens place. So there are two cases that will satisfy. Directly you will get 8 into 9 into 10 into 2 by 3 factorial. So directly the answer is 240. Method number 1 or method number 2. You can take any method of your choice. Method number 1 is comfortable if you are good with the series. Otherwise, this is a place value method. Yesterday we solved a lot of problems based on place value. Tens place greater than units place, tens place less than units place, hundreds place greater than tens place greater than units place. So place value method also you can use it. Place value method also you can use it. I hope the idea it is clear. Now it is best to use the place value method in the 5th one. Place value concept. Place value concept. Yesterday we discussed the 4-digit palindrome, but right now it is 5-digit palindrome. XYZ YX. XYZ YX. Now see here. XYZ YX. So one traditional method is X is less than Y. If X is less than Y. If X is less than Y. If Y is 2. If Y is 2. X it will be 0 and 1. 0 is less than 2, y is less than 2. But x cannot take 0. X cannot take 0. Are you all with me? Like that, if y is 3, x value can take 1 comma 2. 1 comma 2. If y is 4, x value can take 1, 2 and 3. 1, 2 and 3. If y value is 9, x value will take 1 plus 2 plus 3 and 2, 3 till 8. Are you all with me? Z, there is no restriction on Z. Z, there is no restriction. So, Z can take any value from 0 to 9. That means, here, how many values we got? 1 we got, 2 we got, 3 we got, till 8 values we got. Till 8 values we got. 1 plus 2 plus 3 and so on up to 8 values for a corresponding value of y. Into 0 to 9 is nothing but 10 values. So 8 into 9 by 2 into 10 into 10. 2 1s are, 2 5s are. So it is nothing but 360. It is nothing but 360. I hope the idea it is clear. Idea it is clear. XYZ YX. XYZ YX. 1 plus 2 plus 3 and so on up to 8. Why we got 1 plus 2 plus 3 for 8? If y value it is 2, or I will write down here neatly, sir. Please see here. X, y, z, yx. X, y, z, yx. The condition is x is less than y. If x is less than y, if y is 2, if y is 2, x is less than y, x will become 1. That means if it is 1, d is 1, d is 2. Here z can take any value from 0 to 9. Any value from 0 to 9. 0 to 9 means how many cases I got? 10 cases I got. Similarly, if y is 3, y is 3, x is less than 3. If x is less than 3, that means x can take either 1 or 2. Either 1 or 2. If I take this one, this number will become 1, 3. This can become anything from 0 to 9. Again, I will get 10 values. Are you all with me? X can take 2. If x can take 2, x is less than y, 2, 3. This will become 2, 3. Again, it is 0 to 9. Again, it is nothing but 0 to 9. Like that, how many cases did we do any calculation mistake? Let us see. Y is 1, x is 2. If x is 1 comma 2. So here I will get 10 cases. Here I will get 10 cases. Next is x is less than y. If y is 4, x can take 1, 2, 3. X can take 1, 2, 3. 1, 2, 3. 1, 2, 3. Again 10, 10, 10. 30 cases I will get. 30 cases I will get. Are you all with me, right, sir? Next is x is less than y. If x is less than y, if y is 4, 1, 2, 3. Here it is 4 only, right? 4, 4, 4. If y is 5, if y is 5, x will take 1, 2, 3, 4. 1, 2, 3, 4 means 40 cases I will get. Again, x is less than y. If y is 6, again x will take 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Again I will get 50 cases. That means first one I am getting 10. Next one I am getting 20. Next one I am getting 30. So 10 plus 20 plus 30 plus 40 and so on up to 90. Last case is nothing but if y is 6, I am getting 50. If y is 7, I am getting 60. Y is 8, I will get 70. Y is 9, I will get 80. 10, 20, 30 and so on up to 80. 10, 20, 30 and so on up to 80. I hope it is clear, right? This is x value 1, x value, sorry, these y value 2, y value 3, y value 4, y value 5, y value 9. So add all these values. These also and another 10, 20, 30 and so on up to 80. So these are nothing but 8 by 2 into 10 plus 80. 10 plus 80. These are nothing but 45 into 8, which is nothing but 360. 45 into 8, which is nothing but 360. I hope the idea it is clear. Instead of doing these one by one, I did it orally. Just by looking at the question itself, you will get the pattern, sir. If you just closely write it, x, y, z, y, x. X is less than y. If y is 2, x will be 1, z will be 0 to 9. 0 to 9, it is nothing but 10. Similarly, if y is 3, x will be either 1 or 2. Either 1 or 2. So it is nothing but 0 to 9, 0 to 9. Here it is 10 plus 10, 20. That means if you observe carefully here, if y is 2, I am getting a 10. If y is 3, I am getting 20. Y is 2, I am getting 10. Y is 3, I am getting 20. Y is 4, I am getting 30. Y is 5, 40. Y is 9, I will get 80. 10 to 80. Directly you will get the answer. I hope the idea it is clear. These are all some very, very good counting based problems. I hope the idea it is clear. Kindly reply if the logic is clear to each and every one, sir. Logic is clear to each and every one. X, Y, Z, Y, X. X, Y, Z, Y, X. There is a condition on X is less than Y and it is a palindrome. Everybody kindly reply if this logic is clear. 2 I got 10, 3 I got 20, 4 I will get 30, 5 I will get 40, 9 I will get 80. 9 I will get 80. Idea it is clear, right? Next one. Number of polynomials of the form. Another exam model question. There is a cubic expression x cube plus ax square plus bx plus c. D is divisible by x square plus 1. D is divisible by x square plus 1. Now see here. 13. 13 when divided by 5. 5 2s are 10. What is the remainder? 3. So 13 is nothing but 5 into 2 plus 3. 13 is nothing but 5 into 2 plus 3. Dividend equivalent to divisor into quotient plus remainder. So these, I will write down the concept here. Dividend equivalent to divisor into quotient plus remainder. Divisor into quotient. Divisor into quotient plus remainder. This is the concept which I am using it here. There is a cubic expression. It is divided by x square plus 1. What is remaining? In the left hand side there is x cube. Here x square is there. So another x will come. Here there is ax square. So another a will come. So x cube I got, ax square I got, plus x I got. That means minus x I should write. Plus a I got, I should write minus a. What is remaining in the question? Plus bx plus c. Plus bx plus c. So this expression is nothing but x cube plus ax square plus bx plus c is nothing but x square plus 1 into x plus a plus b minus 1 into x plus c minus a. B minus 1 into x plus c minus a. I hope it is clear. These cubic expression is perfectly divisible by this one. That means these remainder should be 0. R of x should be 0. Remainder 0 means b minus 1 should be 0. B is equivalent to 1. C is equivalent to a. How many values it can take? 1 to 10. So how many polynomials which will be formed? 10 polynomials which will be formed. Very, very easy question, right? Just a counting related problem. There is a cubic expression x cube plus ax square plus bx plus c. It is divisible by x square plus 1. So here how to write down this entire expression? That is the root cause. Here it is x cube. I got x square. So in bracket x will come. Here there is ax square. So it will be plus a. X cube plus ax square plus x and it will be minus x. Plus x it will be minus x. Bx is missing. So plus bx. A is not there to the left hand side. So it is minus a. Dividend equivalent to divisor into quotient plus remainder. Divisor into quotient plus remainder. X square plus 1 into x plus a plus b minus 1 into x plus c minus a. This is the remainder. Remainder means b minus 1 should be 0. B value is 1. C and a both are equal. So 1 to 10. Answer is nothing but total 10 values A and C will take where the value of B is fixed. This is another beautiful question based on a polynomial counting related things. I hope this idea it is clear. Next one. How many 2-digit and a 3-digit numbers? How many 2-digit and a 3-digit numbers exist such that Sn plus Pn is n? Sum of the digits plus product of the digits. Sum of the digits plus product of the digits is the number itself. Sn is nothing but the sum of the digits. Sn is nothing but the sum of the digits, and Pn is nothing but the product of the digits. Pn is nothing but product of the digits. Now see here. How many 2-digit numbers? Let n is nothing but 2-digit number AB. Sum of the digits is A plus B. Product of the digits is A into B. A is present in tens place, so the value is 10A. Value of the number will be 10A plus B. B cancel. 10A minus A. 9A minus AB equivalent to 0. A common. A into 9 minus B is 0. A cannot be 0 because A is there in the leftmost. That means 9 minus B is 0. B is nothing but 9. B is nothing but 9. A can take any value from 1 to 9. A can take any value from 1 to 9. So what are the numbers? Numbers is 19, 29, 39 and so on up to 99. 19, 29, 39 and so on up to 99. These are all the numbers. See the sum of the digits. 1 plus 9 is 10. Product of the digits 1 into 9 is 9. 10 plus 9 is 19. Sum of the digits 2 plus 9 is 11. 2 9s are 18. 18 plus 11 is 29. 9 plus 9 is 18. 9 9s are 81. 81 plus 18 is 99. All the values are satisfied. So 2-digit numbers, how many I got? 9. 2-digit numbers, how many I got? 9. I hope the idea is clear. Product of two numbers, if it is 0, either one of them is 0 or both of them has to be 0, right? A cannot be 0 because A is there in the leftmost. Because A is there in the leftmost. I hope the idea it is clear. 19, 29, 39 and so on up to 99. Next one. If it is a 3-digit number, question is 2 digits as well as 3 digits. Let n is nothing but ABC. Sum of the digits plus product of the digits. It is nothing but the number itself. Sum of the digits is nothing but A plus B plus C. Product of the digits is nothing but ABC. A is there in hundreds place. 100A plus 10B plus C. C cancel. 100A minus A, 99A. 10B minus B, 9B, equivalent to ABC. C is nothing but, I am dividing by AB. 99A by AB, 9B by AB. This is nothing but 99 by B plus 9 by A. Why am I writing like this? Because it results in a conclusion. C is 99 by B plus 9 by A. What are ABC here? ABC are nothing but the digits. ABC are nothing but the digits which are less than or equivalent to 9. Less than or equivalent to 0. Right? Suppose if A is 1, B is 1. If A is 1, B is 1. 99 by 1. 99 plus. C will become 99 plus. Meaningless because C is a digit. C is a digit. Even if I give B value 9, which is the maximum value, denominator cannot be 0, so A and B I did not give 0. B is 9. This will be 99 by 9, 11 plus something. 11 plus something is also incorrect. 11 plus something is incorrect, 99 plus something is incorrect. So there are no 3-digit numbers. There are no 3-digit numbers that will satisfy this equation. There are no 3-digit numbers that will satisfy this equation. I hope you understood why I divided by AB, because that will give me a conclusion. If B is 1, 99 by 1 is 99 plus. 99 plus, but C is a digit. A digit cannot exceed beyond 9. If B is 9, it is not possible. If B is 1 also, it is not possible. B value oscillates from 0 to 9. A and B, 0 cannot be given because they are there in the denominator. They are there in the denominator. I hope idea it is clear, right? This is again a CAT original question for your information. This is a CAT original question, right, which involves a little bit of pen pushing. Everybody, I hope it is clear. Kindly reply if the idea it is clear. Sn plus Pn is nothing but En. Sn plus Pn is nothing but En. Sn is sum of the digits, Pn is product of the digits. Sn is sum of the digits, Pn is product of the digits. I hope it is clear. Next one, number of 5-digit telephone numbers. I want 5-digit telephone numbers. These are 5-digit telephone numbers having at least one of their digits repeated. At least one of their digits repeated. At least one. At least one is nothing but total ways minus no digit repeated. At least one is nothing but total minus no digit repeated. At least one is nothing but total minus no digit repeated. So, how many digits in general we use it? We use all the digits from 0 to 9. 0, 1, 2 till 9. We use all the digits from 0 to 9. We use all the digits from 0 to 9. So, total cases, total means, total cases means number of ways with repetition, number of ways with repetition, total cases, number of ways with repetition. So, with repetition means this can take 0 to 9, 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 this can take 0 to 9. So, which is 10 power 5, 10 power 5 minus no digit repeated. Minus no digit repeated is here 0 to 9. So 10, one digit is fixed, remaining 9 digits can come. 2 digits are fixed, remaining 8 can come, remaining 7 can come, remaining 6 can come. So answer is nothing but 10 power 5 minus 10 into 9 into 8 into 7 into 6. 10 power 5 minus 10 into 9 into 8 into 7 into 6. These where I am using a subtraction principle. What is subtraction principle? Total cases minus cases which satisfy the condition. At least one of their digits repeated. At least one of the digits repeated means total cases minus no digit repeated. Total cases is 10 power 5, no digit repeated, 0 to 9, 0 to 9, 10 cases, one digit will happen. So, remaining 9, remaining 8, 7, 6, 10 into 9 into 8 into 7 into 6. 10 into 9 into 8 into 7 into 6. Idea clear, right? At least one is nothing but total minus no digit repeated. Total means I told you yesterday in session number 2, right? In numbers, if nothing is given, repetition of digits is allowed. In numbers, in telephone numbers, leftmost digit can take 0. Number of 5-digit telephone numbers, leftmost can take zeros. So, 0 to 9, 0 to 9, so any digit can come, any digit can come. If you see your telephone number of Hyderabad STD code 040, write 011, 022, 033, leftmost can take digit 0. Leftmost can take digit 0. It is an right telephone number, 5-digit number. In a telephone number, leftmost can take digit 0. Can take digit 0. Rakesh, please have patience till I complete the explanation. I told you at the beginning of the class, till I explain it, have some patience. Right? If you have not read the question properly, and you put it in live chat, you are disturbing the entire class environment. I told you very clearly at the beginning of the class, till I complete a problem, listen carefully, right? Next one. Always you are impatient. Next one. Number of 9-digit perfect squares. Number of 9-digit perfect square ending with number of 9-digit perfect squares ending with 4 nines. 3, 6, 7, 8, 9. Right? Ending with 4 nines. Ending with 4 nines, or it is ending with 4 ones. Ending with 4 ones. Any perfect square ending with 9. Any perfect square ending with 9. 13 square, 116, 9. 17 square, 218, 9. 17 square, 218, 9. Right? Similarly, 9 square, it is nothing but 81. 11 square, it is nothing but 181. Right? These nothing but 19 square, 361. Tens place has to be even. Tens place has to be even. So the answer is no. Answer is no. Right? Tens place has to be no. Tens place has to be no. Right? Jaswant, in that case we may get one digit, 5 zeros. It can't be a number. Why 0 can't be a number? Is 0 not a whole number? Is 0 not a whole number? Please tell me. You are assuming that the number that is present, it should be a natural number. Is 0 not a whole number? 0 is a whole number, right? Next one. Answer is no. Answer is no. Next one. Another question. Find the number of ways in which 4 friends F1, F2, F3, F4. Find the number of ways in which 4 friends. Now please solve this question, sir. Let me see who will get it right. Hotel 1, hotel 2, till 10 hotels. I will write the options. 4 power 10, 10 power 4, 4 power 10 minus 10, 10 power 4 minus 1, 10 power 4 minus 10, 4 power 10 minus 1. Please tell me which one is the right answer. Everybody kindly reply, sir. Everybody kindly reply. The number of ways in which 4 friends can stay at 10 hotels. F1, F2, F3, F4, H1, H2, H till H10. All the friends do not stay in the same hotel. All the friends do not stay in the same hotel. Tell me which out of these 6 options are right, and tell me why it is right. Please everybody kindly reply in the live chat. Everybody kindly reply in the live chat which one you think it is the right answer. Very, very good question. Very, very good question. Find the number of ways in which 4 friends can stay at 10 hotels. All the friends do not stay in the same hotel. All the friends do not stay in the same hotel. All the friends. Everybody kindly give the answer, sir. Everybody kindly give the answers. Everybody kindly give the answers. Other students, Naveen says F is the answer. Other students. Other students kindly reply. Any other answers? Kindly give the answers. 4 power 10, 10 power 4, 4 power 10 minus 10, 10 power 4 minus 1, 10 power 4 minus 10, 4 power 10 minus 1. I'll wait for another 15-20 seconds. Answers: F1, F2, F3, F4, H1, H2, H3 till H10. Now, let me answer. Almost everybody is incorrect. Everyone is wrong. Let us see where you went wrong. First thing, friend will go to hotel. Hotel will not go to friend. A person will go to visit. A person will visit hotel. Hotel will not visit a person. So, friend will go to hotel. These people will go here. Hotel will not go. So, all the friend, read the question. If you read the question, you will get the hint. Find the number of ways in which 4 friends can stay at 10 hotels. All the friends do not stay in the same hotel. These are nothing but total cases minus all the friends staying in same hotel. All the friends staying in same hotel. Am I right? Do not stay in same hotel is total cases. Total cases means first friend can visit any of the 10 hotels. Second friend can visit any of the 10 hotels. Third friend, any of the 10 hotels. Fourth friend, any of the 10 hotels. Minus all the friends staying in the same hotel. All the 4 friends can stay in hotel 1. All the 4 friends can also stay in hotel 2. All the 4 friends can stay in hotel 3. All the 4 friends can stay in hotel number 10. Minus 10. Answer is nothing but 10 power 4 minus 10. 10 power 4 minus 10. Answer is nothing but 10 power 4 minus 10. So, all the friends do not stay in the same hotel. It is nothing but total cases minus all the friends staying in the same hotel. Total cases is first friend can visit any of the 10 hotels, 10 cases. Second friend also 10 cases. Third friend 10 cases. Fourth friend 10 cases. Total cases is 10 power 4. All the friends staying in the same hotel. Same hotel means it could be H1 or H2 or H3 or H10. So, they can all stay in the same hotel 10 ways. That means these nothing but either H1 or H2 or H3 or H10 or H10. So, 10 power 4 minus 10. 10 power 4 minus 10. All the friends staying in same hotel. There is one way like that. Hotel 1, Hotel 2, Hotel 3, there are 10 different hotels. All of them can stay in Hotel 1 is different from staying in Hotel 2. So, answer is 10 power 4 minus 10. 10 power 4 minus 10. 10 power 4 minus 10. Very, very good question. Please make a note of it. Very, very good question. Next one. Find the number of all the possible selections which a student can make for answering one or more questions out of 8 questions. Question number 1, there are 2 alternatives. Question number 2, there are 2 alternatives. Question number 3, there are 2 alternatives. Like that, question number 8, there are 2 alternatives. Again, I will give you answer options. Again, I will give you answer options. Please tell me which one is the right answer. Please tell me which one is the right answer. All are very, very good questions, sir. Find the number of all the possible selections which a student can make for answering one or more questions. One or more questions out of 8 given questions where each question has 2 alternatives. Where each question has 2 alternatives. Question number 1 has got 2 alternatives. Question number 2, question 3, question 4. Let me know which answer is right. Everybody kindly participate in the class, sir, so that you will come to know if you are doing any mistake. You are doing any mistake, you will come to know. I will be there to help you out in terms of some clarity. Question 1, 2, 3 till 8. Which one you think is the right answer? Which one you think is the right answer? Read the question properly, you will come to know. 1 minute time, kindly mention your answers. Kindly mention your answers. Kindly mention your answer. Some are saying option E, some are saying option B. Any other? Any other options? So, people are saying the right answer for this question is 3 power 8 minus 1. Right answer for this question is 3 power 8, right, minus 1. First, we will read the question. Find the number of all the possible selection which a student can make for answering one or more question. One or more is nothing but at least one. Am I right? At least one is nothing but total minus none. Total minus none. Total minus none. None. Total is, suppose if this paper is given to him for 8 questions. Total means, suppose in question number 1, there are how many ways to solve a question? He can tick mark option A. He can tick mark option B. Or he decided not to solve a question. I decided not to solve a question is also one of the way of solving a question. Suppose I went into the CAT examination. I went into the CAT examination. I did not do anything. 2.5 hours I just slept in the examination hall. Clicked on the submit button and I left. Did I attempted the paper? Yes. Did I attempted any questions in that paper? No. Right? So question number 1, either option 1 I can tick mark, option 2 I can tick mark. I will decide not to solve a question. Right? That is also one of the way. So option A, option B, not tick marking any option A or B. Not tick marking any option or B. So these are nothing but 3. 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 These are nothing but 3 power 8 minus 1. These are nothing but 3 power 8 minus 1. These are nothing but 3 power 8 minus 1. 3 power 8 minus 1. What is this one? You decided not to attempt the paper. Answering one or more questions is nothing but, at least one is nothing but total minus none. At least one is nothing but total minus none. So, which is nothing but 3 power 8 minus 1. At least one is nothing but total minus none. So, 3 power 8 minus 1. 3 means either option A or option B, or deciding not to solve a question. Or deciding not to solve a question. I hope it is clear. Answering one or more is nothing but at least one. At least one is nothing but total minus none. At least one is nothing but total minus none. I hope the idea it is clear. Next one. A is nothing but 1, 5, 9, 13 till 103. Find the maximum number of elements. Maximum number of elements that can add up to 1094. These are nothing but 1, 5, 9, 13 and so on up to 1093. 1093. Last term it is nothing but 1093 is a plus n minus 1 into d. D is nothing but 1092 equivalent to n minus 1 into 4. N minus 1 is nothing but 4 2s are 829, 273. N is nothing but 274. 274 elements are there. If you observe, first one and last one, 1093. The sum is nothing but 1094. 4 added here, 5. 4 if I decrease, 1088. 4 added, 4 decrease, 1089. Again it is 1094. That means 137 values are on the left hand side. It will get added with 137 on the right hand side to get the sum 1094. Answer is how many values? Maximum number of elements, which is nothing but 137. Which is nothing but 137. Now, next question. This is a very easy question, sir. 3 dice are rolled. Find the number of possible outcomes. Find the number of possible outcomes in which at least one die shows 5. At least one die, at least one sees nothing but total minus none. At least one sees nothing but total minus none. At least one is nothing but total minus none. Total minus none. In a die will have a numbering from 1 to 6. A die will have a numbering from 1 to 6. So here it is 6. Here it is 6. Here it is 6. So it is nothing but 6 cube minus 5 cube. Don't take 5. Don't take 5. Don't take 5. So I will get the cases 5 into 5 into 5. Answer is nothing but 216 minus 125. Answer is nothing but 91. Answer is nothing but 91. At least one sees nothing but. At least one sees nothing but total minus none. At least one is nothing but total minus none. At least one sees nothing but total minus none. 6 into 6 into x. These are the total cases. First die can show any number from 1 to 6. Any number from 1 to 6. 6 into 6 into 6 minus 5 into 5 into 5. 216 minus 125. Answer is nothing but 191. It is clear? Now, from here onwards, number related problems. Every question is extremely important, sir. Number related problems. Listen carefully, sir. Each and every problem is extremely important. Number related. This is the question number 1. Each and every, this is question number 2. All are these question number 3. This is question number 4. Again it is question number 5. All are based on digit related. Question number 6. Question number 7. Question number 8. Question number 9. All are based on number and digit related. Right? Question number 10. We will solve these 10 questions. Next will come sum of the digits. Another important logic, sir. Sum of the digits probably in the evening session, which will cover in the sum of the digits. How many problems are there? 1. Where the repetition is not allowed. Repetition is allowed. Digit 0 is not there. Repetition not allowed with the digit 0. Repetition allowed with the digit 0. Repetition is allowed with digits getting repeated. 5. Right? Next, another exam model question. Question number 6. Question number 7. Sum of the digits. Evening class will also be. Right? Again, question number 8. 9. All these we are going to discuss today, sir. Question number 10. I think these we can solve it today only. These are all based on digits. Now see here. Now we will solve these questions digit related. A book has 252 pages. Listen carefully, sir. A book has 252 pages. How many digits are used to number all these pages sequentially starting from 1? So first page 1 to 9, total 9 digits I will use. Next one 10 to 99, 10 to 99, totally 90 numbers are there. Every number I am taking 2 digits, 90 into 2, 180. From 100 to 252, 100 to 252, total 153 numbers are there. Every number I will take 3 digits. So these is nothing but 459. So add all of this. 459 plus 189. Total 648 digits are used. Total 648 digits are used to number the pages sequentially starting from 1, where a book has 252 pages, where a book has 252 pages. So answer is nothing but 648 digits. 1 to 9, there are 9. 10 to 99, 90 numbers are there, every number 2 digits. 100 to 252, 153 numbers are there, every number it is 3 digits. So 153 into 3 is 459. 459 plus 189, 648 digits. Now see here. If I write all the natural numbers from 1 to 452, how many digits will be required? Let us solve this question. 1 to 9, again 9 digits exhausted. 10 to 99, total 90 numbers. Every number 2 digits, 90 into 2, 180. 100 to 452, 100 to 452, total 353 numbers. Every number 3 digits. These 9. These nothing but 1059. 1059 plus 189. These nothing but 1248 digits have been used. 1248 digits have been used to write all the natural numbers from 1 to 452 sequentially. From 1 to 9, 9 digits are used. 10 to 99, 90 numbers, every number 2 digits are used. 90 into 2, 180. 100 to 452, 353 numbers are there, every number 3 digits are there. So which is nothing but 1059. Which is nothing but 1059. Next one. Oh, this I will. Now, please make a note of it. Make a note. Suppose in a set of 1 to 100 natural numbers, in a set of 1 to 100 natural numbers, let us see some pattern. In a set of 1 to 100 natural numbers, where all 5 will come, let me write. 0, 5, 15, 25, 35, 45, 55, next is 65, next is 75, next 85, next 95. Or it can also be 50, 51, 52, 53, 54, 55. Already I wrote 55, eliminated. 56, 57, 58, 59. Now, please see here. Listen carefully, sir. In a set of 100 natural numbers, how many times 5 appeared minimum once? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here also it is from 0 to 9, 10. But this is eliminated. That means in a set of 100 consecutive natural numbers, any non-zero digit, please make a note, sir. Any non-zero digit appears, any non-zero digit appears 20 times but in 19 numbers. 20 times but in 19 numbers. 20 times but in 19 numbers in every 100 consecutive natural numbers. In every 100 consecutive natural numbers. Please make a note, sir. Any non-zero digit appears 20 times but in 19 numbers, because there is one number where it appears twice. There is one number where it appears twice. 55, where it appears twice. Where it appears twice. Any non-zero digit appears 20 times but in 19 numbers, because there is one number where it appears twice. Very, very important learning. Any non-zero digit appears 20 times but in 19 numbers. Now let us go with this question. If we write all the natural numbers from 213 to, for example, 412, there are 200 natural numbers. There are 200 natural numbers. Already we have seen in every 100 natural numbers, every single non-zero digit appears 20 times but in 19 numbers. I want for 200 natural numbers. So this appears 40 times but in 38 numbers. 40 times but in 38 numbers. 40 times but in 38 numbers. Till 412 it is over. 415, 425, 435, 445. Next it is 450. 451, 452, 452. 1, 2, 3, 4, 5, 6, 7. So, in how many times it is appearing in the remaining? It is appearing in 7 times in 7 numbers. That means total how many times it is appearing from 213 to 452? 47 times it is appearing. In how many numbers it is appearing? 45 numbers it is appearing. 45 numbers it is appearing. There are some numbers, if you observe closely, 255, 355, where 5 is appearing twice. Very, very easy concept if you know this concept. In a set of 100 natural numbers, every single non-zero digit appears 20 times but in 19 numbers. Every single non-zero digit will appear 20 times but in 19 numbers. Extremely important concept. Extremely. Even if it is, suppose for example, even if it is from 213 to 652 also, you can easily solve. From 213 to 612, how many numbers are over? 400 numbers are there. Afterwards, count it. 615, 625 till 645. Next it is 650, 651, 652. I hope the idea is clear. These are most frequently asked questions, sir. It is clear, right? Now let us solve this question. If we write all the natural numbers from 1 to 100, how many times digit 7 will appear? Digit 7 will, any single non-zero digit appears 20 times but in how many numbers? 19 numbers. Directly answer is, it will appear 20 times but in 19 numbers. It will appear 20 times but in 19 numbers. I hope the idea it is clear. These are all sum of the digits. Very easy once you understand it. But before that, let us solve some questions related to digit based. Find the number of times the digit 5 will be written. Find the number of times the digit 5 will be written while listing all the natural numbers from 1 to 1000. Listen carefully, sir. You are listing all the integers from 1 to 1000. You are listing all the integers from 1 to 1000. That means you are listing single digit numbers. You are listing 2-digit numbers. And you are also listing 3-digit numbers. You are also listing 3-digit numbers. So, I will put like this. If it is 5, number of times the digit 5. Number of times the digit 5 will be written while listing all the integers from 1 to 1000. If 5 is there here, this can be 0 to 9, yes or no? 0 to 9, 0 to 9. Why? Because if it is 0, I will get all the possible 2-digit numbers. Again, it can be from 0 to 9. Again, it can be from 0 to 9. Because if this is 0, this is 0, I will get all the possible single digit numbers with a digit 5. So 10 into 10, I will have 100. 10 into 10, I will have 100. If the tens place, if it is 5, this can be from 0 to 9. This can be from 0 to 9. So 10 into 10, again it is nothing but 100. Again, if 5 is there in hundreds place, again it will be from 0 to 9. This will be from 0 to 9. 10 into 10, it is nothing but 100. Either 5 can be in units place, or 5 can be in tens place, or 5 can be in hundreds place. Answer is nothing but 300. Answer is nothing but 300. Now a smart student might get a doubt. Hey Anil sir, but you did a repeat counting of the number 555. 555 is present in the first case. 555 is present in the second case. 555 is present in the third case. 555 is counted thrice because 5 is present thrice. I need to count the number of times digit 5 is present. I am not interested in counting the numbers. In a number, if a digit 5 is present twice, I will count it as twice. 555 case 1, case 2, case 3. 555 is counted thrice because 5 is present thrice. 5 is present thrice. 255. 5 is present how many times? 2 times. Answer also 255 should be counted twice. 255. 255. Here 255. 255 is counted. 255 is counted twice because 5 is present twice in that number. Please write down that point, sir. Number is counted that many times. 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 The digit n is present in that number. Digit n is present in that number. Digit n is present in that number. Again, I am explaining, right? It maximum possible 3 digits is 999. If 5 is there in the units place, 0 to 9, 0 to 9, 10 tens are 100. Why I kept leftmost 0? If the leftmost is 0, I will get all the possible 2-digit numbers also. 5 can be present in the tens place, 0 to 9, 0 to 9, 10 tens are 100. 5 can be present in the hundreds place, 0 to 9, 0 to 9, 10 tens are 100. 100 plus 100 plus 100. Answer is nothing but 300. Very, very important point. Any non-zero digit is present 300 times in any, when you are writing natural numbers from 1 to 1000. Any non-zero digit is present 300 times when you are writing the natural numbers from 1 to 1000 sequentially. I hope it is clear. Number is counted that many times the digit is present in that number. Again, I am repeating. Number is present that many times the digit is present in that number. Suppose 155. 155, 5 is present twice. If 5 is present twice, if 5 is present twice, 155, 155, 155 is present. 155 is counted twice because 5 is present twice. I hope it is clear. Kindly reply in the live chat if this is clear to you. Is this clear to you? Kindly reply. Is this reply right? Is this concept clear to you? Kindly reply, sir. Each and every problem kindly listen with utmost attention, sir. 10 into 10, 100, 100, 100. Why the leftmost can take 0? If the leftmost is 0, I can write all the possible two-digit numbers. If the leftmost two are 0, 0, I will get single-digit number. When you are writing from 1 to 1000, you are writing single digits, two digits, and three digits. You are writing single digits, two digits, and three digits. Number is counted that many times, the digit n is present in this number. Everybody please reply, sir. Everybody kindly reply. Everybody kindly reply. Naveen says yes. Other students kindly reply. Right? Next one. Find the sum of all the digits in the decimal representation of all the positive integers less than 1000. Sum of all the digits. Each digit. What are the digits that are present? Digits that are present are 0, 1, anyway 0 into anything, 0 it will be. So 0 I can eliminate it. Each digit is present. How many times? Each digit is present 300 times. Each digit is present 300 times. Find the sum of all the digits. 1 will come 300 times, 2 will come 300 times, 3 will come 300 times, 9 will come 300 times. Sum. So 300 into 1 plus 2 and so on up to 9. These are nothing but 300 into summation 9 is 45. Finish. Summation 9 is 45. Each digit will come 300 times. 1 will come, 2 will come, 3 will come, 4 will come. Similarly, 9 will come. 300 into summation 9. Summation 9 is nothing but 45. So, sum of all the digits that are coming is nothing but 300 into 45. 300 into 45. Next one. How many integers from 1 to 1000 will have digits appearing at least once? Method number 1. Method number 1. Appearing at least once. At least once. At least once is nothing but total minus none. At least once is nothing but total minus none. So, total numbers is nothing but from 1 to 1000 I am writing. So, leftmost. So, 0 to 9, 0 to 9, 0 to 9. 10 into 10 into 10, 10 cube. All the cases cannot be 0 because it is starting from 1. These are the total cases. Minus, minus. Here 0 to 9, 5 should not come. 0 to 9, 5 should not come. 0 to 9, 5 should not come. 0 to 9 is 10, 5 cannot come. So, it is 9 cube. Again, all the 3 cannot be 0. Answer is 10 cube minus 1 minus of 9 cube minus 1. So, answer is 10 cube minus 9 cube, which is nothing but 1000 minus 729, which is nothing but 271. Which is nothing but 271. Which is nothing but 271. 0 to 9, 0 to 9, 0 to 9. So, it is 10 cube. All the 3 cannot take 0. So, 10 cube minus 1. These are the nothing but the total cases. None means you should not take 5. 0 to 9 total 10 digits are there. 5 cannot be taken. 9, 9, 9. 9 cube, all the 3 values cannot take 0. So, it is 9 cube minus 1. At least once, I am using subtraction principle here. At least once is nothing but total minus none. At least once is nothing but total minus none. At least once is nothing but total minus 9. This is method number 1. Method number 2. Method number 2. At least once. At least once is nothing but case 1. Only once. Case 2. Only twice. only twice. Case 3, thrice. At least one means minimum once. So either once or twice or thrice. Thrice means only 555. It is nothing but 1. 555 is nothing but 1. Only twice is nothing but. It can be 55 or 55 slash or slash 55. Am I right? Here it can be 0 to 9. 5 cannot come again because 5 only twice. Here it is nothing but 0 to 9, 5 cannot come. Here it is nothing but 0 to 9, 5 cannot come. 0 to 9 is 10, 5 cannot come. Here 9 cases, here 9 cases, here 9 cases. So 9 plus 9 plus 9, which is nothing but 27. Only once is either it can be like this, or it can be like this, or it can be like this. Are you all with me? Only once. 5 can be present in units place, tens place, or hundreds place. Units place, tens place, or hundreds place. These 0 to 9, 5 cannot come. 0 to 9, 5 cannot come. 0 to 9 is 10, 5 cannot come. 9. 9 nines are 81. 5 can be moving from units, tens, and hundreds. 81 into 3 is 243. So answer is nothing but 243 plus 27 plus 1. So answer is nothing but 271. Answer is nothing but 271. I hope the idea it is clear. Method number 2. Method number 2 is nothing but at least once. At least once is nothing but only once, only twice, and thrice. Only once. Only one is either 5 can be present in units place, or tens place, or hundreds place. Only twice. It can be present in 2 positions. Thrice is 555. This is method number 2. Method number 2. Now see here. Method number 3. Method number 3. What is the concept that we discussed? In a set of 100 consecutive natural numbers. In a set of 100 consecutive natural numbers. In a set of 100 consecutive natural numbers. Every digit appears 20 times but in 19 numbers. Every non-zero digit appears 20 times but in 19 numbers. Every non-zero digit appears 20 times but in 19 numbers. Now see here how we will solve it. From 1 to 1000, anyway, from 500 to 599, 500 to 599, definitely every digit contains 5. 500 to 599, every digit contains 5. So 100 it is over. So out of 1000, 100 we have to subtract. Why? Because if 500 to 599, every digit contains 5. Remaining 900 numbers are there. In every 100 numbers, it will appear in 19 numbers. Numbers only we require. But in the remaining 900 numbers, how much it will be? It is into 9, so it is 171. So answer is 100 plus 171, which is nothing but 271. You can use any logic to get the answer. You can use any logic to get the answer. Method number 3. In a set of 100 consecutive natural numbers, 100 consecutive natural numbers, every single non-zero digit appears 20 times but in 19 numbers. Every single non-zero digit appears 20 times but in 19 numbers. In 1 to 1000, 500 to 599, definitely 5 will be present. So 100 numbers, 5 will be present. Remaining 900 numbers, for every 100 numbers, 19 numbers, it will appear at least once. 900 numbers, 9 into 19 is 171. 100 plus 171 is 271. Method 1, method 2, method 3. Method 1, method 2, method 3. You can choose any method that comes into your mind. Next one. How many 3-digit numbers do not have digit 5 in them? How many 3-digit numbers do not have digit 5 in them? Method number 1. Method number 1. It is a 3-digit number. Digit 5 should not be present and it is a 3-digit number. So leftmost cannot be 0. It is a 3-digit number. So leftmost cannot be 0. So 1 to 9. Digit 5 should not be present. 1 to 9 total, there are 9 digits. Digit 5 should not be present. 8. Out of 10 digits, here 0 to 9, 5 should not be present. 5 should not be present, which is 9. Here 0 to 9, 5 should not be present. Again 9. Again 9. Answer is 81 8s are 648. Answer is 81 8s are 648. Digit 5 should not be present. Digit 5 should not be present. Method number 2. Sir, can I use that 19 number logic? You can use. 3-digit numbers. 3-digit numbers start with 100 and end at 999. 3-digit numbers start at 100 and end at 999. So total numbers is nothing but 900 3-digit numbers are there. Out of which 500 to 599. 500 to 599. In these definitely 5 will be there. We have to subtract. Out of 900, 100 numbers, digit 5 is definitely present. Remaining is 800. In every 100 numbers, it is present in 19 numbers. 800, 8 into 19. So 800 minus 152. Answer is nothing but 648. Answer is nothing but 648. Answer is nothing but 648. I hope, right? The logic is clear. Method number 1. 3-digit numbers do not have digit 5 in them. 1 to 9, 5 is not present. 0 to 9, 5 is not present. 0 to 9, 5 is not present. 648. Method 2. Total 3-digit numbers are from 100 to 999. 900 numbers are there. In that one, 500 to 599. 100 numbers. 5 will definitely be present. But the question is, it do not have digit 5 in them. It do not have digit 5 in them. So I need to subtract. So total 800. In every 100 numbers, single digit will be present in 19 numbers. So it is 8 into 19. 800 minus 152 is 648. 800 minus 152 is 648. I hope it is clear. Now in previous case, all the 3 methods, you are getting the same answer, 271. It is nothing but, I hope these 3 problems are clear to you, sir. I hope these 3 problems are clear to you. Kindly reply in case you got a doubt in this method. 648. Again, method 1, method 2, method 3. Next, sum of the digits, right? This is a very, very important concept, especially from an examination perspective, sir. Very, very important concept. Extremely important concept. I hope the idea it is clear. One more question. How many 3-digit numbers are there in which digit 5 is used exactly once? Digit 5 is used exactly once. Digit 5 could be used exactly once in units place, tens place and hundreds place. Here 1 to 9, 5 cannot be used. Here 0 to 9, 5 cannot be used. Here 1 to 9, 5 cannot be used. Here 0 to 9, 5 cannot be used. Here it is 0 to 9, 5 cannot be used. 0 to 9, 5 cannot be used. 5, only the leftmost cannot take 0. 1 to 9, there are 9 numbers which 5 cannot be used. It is 8. 0 to 9, 10, 5 cannot be used. 8 into 9, which is 72. 1 to 9, 5 cannot be used. 8 into 0 to 9, 10, 5 cannot be used. It is 9. 8 into 9, 72. 0 to 9, 10, 5 cannot be used. 9 into 9, 9 into 9, 81. So, answer for this question is 144 plus 81, which is nothing but 225. How many 3-digit numbers are there? How many 3-digit numbers are there in which digit 5 is used exactly once? Answer is nothing but 225. Answer is nothing but 225. Why these 8 into 19? In every 100 numbers, digit 5 is present in 19 numbers. In 800 numbers, how much it will be? 100 8s are 800. It is nothing but 19 into 8. It is nothing but 19 into 8. I hope this idea it is clear, right? Next one. So, digit 5 can be used at least once in units place or tens place or hundreds place. Units place, tens place or hundreds place. Leftmost cannot be 0. Rightmost it can be 0. 72. 72 plus 72 plus 81. 72 plus 72 plus 81. I hope the idea it is clear. How many 4-digit numbers are there in which digit 5 is used? Exactly twice. So, it is a 4-digit number. 5 is used exactly twice. Exactly twice means total out of 4 places, 2 places, 6 cases will come. What are that 6 cases? Once we write, you will understand it clearly. 5 5 slash slash 5 slash 5 slash 5 slash slash 5. These are the 3 cases. Units place, tens place, slash slash 5 5 slash slash 5. Units place, tens place, units place, tens place, hundreds place, slash 5 5, and it is a slash. Please write down. Slash. These are the 6 cases. Am I right? So, 4-digit numbers, it can take units tens, you can take units hundreds, it can take units thousands. It can take tens and hundreds, it can take tens and thousands, and it can take. Now, the problem is very easy. So, this will be 0 to 9, 5 cannot come. 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 Right? 0 to 9, 5 cannot come. 0 to 9, 5 cannot come. Leftmost only it cannot take 0. 1 to 9, 5 cannot come. 0 to 9, 5 cannot come. Here it is 1 to 9, 5 cannot come. Here it is 0 to 9, 5 cannot come. Here it is 1 to 9, 5 cannot come. Here it is 0 to 9, 5 cannot come. So, 1 to 9, there are 9 numbers. These are nothing but 8 into 9. These are nothing but 8 into 9. These also again nothing but 8 into 9. 8 into 9, 8 into 9. These are nothing but 9 into 9, 81. Here also it is nothing but 81. Here also it is nothing but 81. 81 3s are 243. 72 3s are 216. So, answer is nothing but 459. 459. Exactly once we used and exactly twice also we used. Right? Twice. So it can be taking out of 4 positions, it can take any 2 positions. So 4C2, total 6 vases I will come. Units tens, units hundreds, units thousand. Tens hundred, tens thousands, and hundred and thousand. Total 6 cases. Leftmost cannot take 0. Leftmost cannot take 0. Leftmost cannot take 0.